Hello and welcome back. In this video we'll talk about quotients of powers. Quotients are a fancy way of saying division problems. Start off with something simple, 3 to the 5th power over 3 to the 2nd power. If we were to expand that, we would see we have 3 times 3 times 3 times 3 times 3. We'd have that 5 times. And that whole thing would be over 3 times 3, 2 times. Well, if we look at the first set of 3 divided by 3, we know that that becomes a 1. And the second set of 3 divided by 3, that becomes a 1 also. So basically we have two 1s multiplied by 3 times 3 times 3, which eventually would give us 3 to the 3rd power. And you notice that the whole thing is over 1. So the shortcut to this would be to take your 3 to the 5th power and minus the 2 power on the bottom. So you always take the numerator and subtract the denominator. So 3 to the 5th minus 2 is going to give you 3 to the 3rd power. So we had more 3's on top than we did on the bottom, so we ended up with more 3's on top and no 3's on the bottom. And this will also work with variables. Let's suppose we have n to the 12th power over n to the, let's call it 5th power. That would equal n to the 12 minus 5, which is going to give you n to the 7th power. Well, what if it was the other way around? What if it was n to the 5th power over n to the 12th power? Well, we would have n to the 5 minus 12, which would give us n to the negative 7th. And technically, that's what it would equal, unless your expected response would be to have no negative exponents. Now, if we wanted to, we could call this 1 over n to the positive 7th, because that is the reciprocal equivalency of n to the negative 7th. If we have multiple parts, let's say we have something like x to the 5th power, y to the 4th over x to the 3rd power. Well, only the x's can cancel each other out. So we would have x to the 5 minus 3 times y to the 4th. And since there's not going to be any more x's on the bottom, we can put this over 1, or we can just leave no 1 under the bottom. Keep simplifying. X to the 5 minus 3 is going to leave you with x to the 2nd power times y to the 4th. So this original problem here simplifies out into x squared times y to the 4th. Let's try it again. Let's suppose we have a to the 3rd, b to the 7th over a to the 5th, b to the 4th. Okay, so we would have a to the 3 minus 5 times b to the 7 minus 4, and that would simplify out into a to the negative 2, b to the positive 3, and technically this is equivalent to the original problem, but some people prefer not to have this negative exponent. It just depends on what the instructions are. Now, to get rid of that negative exponent, you're going to take it and put the whole thing in the bottom and rewrite it with a positive. So the b to the 3rd is a positive already, so we're going to leave it on top. And the a to the negative 2nd will go to the denominator as a to the 2nd. One thing I like to show students is, okay, where are there more exponents? Well, there's more on the bottom. So I'm basically going to get rid of all 3 on top, and I'm going to leave only 2 on the bottom, and that's a shortcut of doing that. Same thing with the b's. I have more b's on the top, so I'm going to get rid of the b's on the bottom and replace that 7 with how many more b's it has on top, which is 3. So there is a shortcut to this.